Everyone, welcome to Cassandra Lunch number 115. We'll go ahead and give everyone a couple more minutes to file in and we'll get started. Everyone, welcome to Cassandra Lunch number 115. We'll give everyone another minute or so to file in. Alrighty, let's go ahead and cut the music. Hey everyone, welcome to Cassandra Lunch number 115. Today's talk is going to be on Google Dataproc and DataStax Astra. I will be the speaker for today. My name is Arpan Patel. I'm an engineer here at Anant. Coordinators for this event are Rahul and myself. If you are interested in giving a talk here at Cassandra Lunch, feel free to reach out to me. My email is listed below. Also, if you're interested in giving a talk at our sister lunch, Data Engineers Lunch, feel free to reach out to me as well. Or if you're interested in sponsoring either of the two events. We are a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, or sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So if you're interested in all the various events, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem, whether that be open source, enterprise, like DataStax, Scylla, Yugabyte, key spaces, Cosmos DB, as well as managed open source like Avon or Instacluster, as well as things in the ecosystem like Spark, Kafka, Airflow, etc. So if anyone's new here in the YouTube chat, don't forget to say hi, hello. Don't forget to like and subscribe as well. Group rules, if you have a question, feel free to ask it in the YouTube chat, as well as if you know anything on the topic, feel free to talk about your experiences. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. GW University helps provide venue space when we have in-person events. We also have some organizational institutional sponsors. If anyone has any jobs that they're offering or looking for jobs, feel free to drop links in the YouTube chat. Or if anyone has any meetups, hackathons, conferences, or classes they would like to promote, feel free to drop those links in the chat as well. We are hiring here at Anant, full-time, part-time positions, data platform operators, engineers, architects. You can find out more at careers.anant.us. Upcoming events, Cassandra lunches happen every Thursdays at noon Eastern, as well as data engineers lunches, which happen on Mondays at noon Eastern. I will also be giving a talk on Monday related to Apache Airflow and Google Dataproc. So what we're going to be covering here today, we're going to essentially orchestrate it with Airflow, and we'll show you how that can be done versus the manual stuff we do today and how that maps to the actual Airflow DAG. So if you're looking forward to it, don't forget to like and subscribe. All these videos are available on our YouTube channel, youtube.com/AnantCorp, and you can find all of the Cassandra Lunch videos starting from Cassandra Lunch number 10 all the way till today, 115, on that playlist. Cassandra.Link should be a more resource for all things Cassandra. This website is powered by hand-curated sites by the team here at Anant. So anything that is a video, newsfeed, resource in the context of Cassandra, we've curated it and it's available on Cassandra.Link. We've also released our 9th free Apache Cassandra runbook. This one covers getting started with Cassandra troubleshooting, some tips and know-hows, as well as restarting the service and troubleshooting down alerts, essentially. So if you're interested in that, we will drop the link in the YouTube chat. And with that, we will go ahead and move on to today's topic. So let me swap slide decks here. Alrighty. So as mentioned before, today's talk is going to be on specifically Google Dataproc and DataStax Astra and some of the things that we'll need to get that connection working. But on Monday for Data Engineers Lunch, we'll show you how to do this exact same thing, but essentially wrap it and orchestrate it with Airflow. But today we're mainly going to be focusing on what's needed for the Dataproc aspects and what's needed for the Astra aspects. And so if you're not familiar with Google Dataproc, it's a fully managed, highly scalable service for running Spark, Flink, Presto, as well as other open source tools and frameworks. It lets you take advantage of open source tools for batch processing, streaming, machine learning, etc. So essentially, for our use cases today, we're going to be focusing on the Apache Spark aspect of it. But when we're deploying a cluster, we'll show you what it looks like if you want to add extra components like Presto or Flink or etc. Dataproc clusters are easy to and fast, and we'll take a look at it once we actually do it, to start, scale, shut down. We're not going to be looking at the scaling part of it. We're just going to be looking mainly at the start and shutdown aspects. And then on average, they report that starting these specific operations take around 90 seconds or less. But one of the main things here is that it has built-in integration with their platform. So today we'll be using the Google Cloud Storage, and we'll see how that native integration works across GCP systems. But you can also look at connecting BigQuery, Bigtable, logging, which we can also use. So when you use Dataproc, it has like stage buckets that it auto creates for you, which stores logs there, but you can also see them within the actual job execution itself. You can also use cloud monitoring as well. And one of the main things, essentially, again, as mentioned, that we'll see on Monday is that you can interact with clusters using Spark, Hadoop, or PySpark, RSpark, all the various distributions via the Cloud Console. You could use the SDK. We'll be using the Google provider when we look at Airflow on Monday. Or the REST API, which essentially is what we're doing, right? The operator is essentially the APIs talking to each other. So structure that the DAG will be in is similar to how the API, REST API works, but there are some things I note in that documentation or in the actual DAG code related to how the actual key values of the API map to the settings you have to set in the DAG code. But again, that's something we'll look at on Monday. Today it's just mainly going to focus on manually create a Dataproc cluster and then talk to Astra, right? So we'll take a look at these resources in a second, but there's different machine versions and image versions that you can use with Dataproc, and each one has different, well, not necessarily has different, but depending on the machine version or image version, you have different compatibilities of your tools, right? And we'll take a look at those matrices in a second. But in general, Dataproc can run on GCE, so Compute Engine, or GKE, which we'll be running it today and on Monday on GCE, so Compute Engine. We might have a talk later in the future related to how to get this working with even Airflow on GKE and then Dataproc on GKE and using virtual cluster config. But I won't go too much into that for now, but we're just going to be focusing on GCE for Dataproc. And Dataproc also has a serverless option for Spark. And then there's a breakdown matrix of serverless for Spark versus if you're running it on Compute Engine, GCE. So we see here that processing frameworks, if you're using serverless, You have Spark 3.2, but for Dataproc, you can use 3.1, or you can also use 2.4, which we'll talk about in a second when we look at these documents here. And then you could also have startup time. So it looks like startup type on average is faster when you're using serverless, obviously, which makes sense. But then you don't have things like VM access, for example, SSH, which we'll actually be taking a look at today, and we'll show you what that looks like. If you want to actually SSH into, say, for example, the master node, and you just want to test out some Spark shell commands, it's very simple to do, and we'll show you how to do that, but we won't go too in depth with it. So yeah, if we move on to what is required for the aspects of actually using Dataproc to talk to DataStax Astra, right? So there's two main things we have to look at, right? So the first main thing is on cluster deployment. So one of the properties we have to set is a Dataproc property, and this property is called conscript provider enable, and we have to make sure that's enabled to false. And then when we're actually submitting a job to that cluster, we need to make sure we are also passing in our Spark Cassandra connector. This version we're going to be using here, 3.1.0 maps to Spark 3.13. Again, we'll take a look at the compatibility matrix in a second. But if for, say, you're using Spark 2.4 on a different Dataproc image, you would need to have the connector for that specific version. So something to just keep in mind there, but we're just going to be using default 3.13 Spark and the 3.10 Spark Cassandra connector. All right, so with that, let's take a look at this compatibility matrix that I was referring to. So as mentioned, there are different images. You have the Debian image, the Ubuntu image, and Rocky Linux. No matter which one of these links you click on, it'll have all of the images for you so you can see it. So the main things we want to look at here are the Dataproc versions, right? So Dataproc 2.0.x and then Dataproc 1.5.x, right? So what we're going to be using today and for default is going to be Debian 2.0.x. And so you can see here that it has Debian and then Rocky. And so each version has this list, right? So what we're going to be looking at here, as while I was working on this and trying to debug it, looking at version numbers. So we see here that Spark is installed with 3.13. And then if we scroll a little bit further down, we can see the Scala version 2.12.14, right? Versus if we're using Dataproc, and this is Dataproc 2.0.x, right? So, but if we're using Dataproc 1.5 and you have workloads using Spark 2.4, you would probably want to launch your Dataproc clusters with versions, Dataproc images, like one of the ones listed here, right? Because like if we scroll down to the 1.5 release versions and we look at the Spark version, so we see here, if you want to use Spark 2.4.x, you can use it this way. So you would just need to change the version, the image version you're using. But again, you can do this when you're doing your launch, or if you're using the REST API, or if you're using a DAG, you can set that in the config. But again, we'll talk about that on Monday. But let's go ahead and move on to the demo portion. So for the demo, let's go ahead and close these out real quick. What we're going to be focusing on is we're going to spin up a Dataproc cluster. And again, we're going to be using that specific Dataproc conscript enabled as false. We're going to place a jar and a secure connect bundle into our GCP bucket. And then we're also going to submit a Dataproc job, Spark job specifically, which is going to run a select all.show from database, Astra database.keyspace.table. So you can use this jar when the source code is available on Monday with all the DAG and everything to run this against your own workloads. So we'll show you what the arguments look like and the order of the arguments that are needed. And then we'll also take a look at the Spark shell, like I mentioned before, on the master node, so we can SSH into it just in the UI itself. It'll open a pop-up, but once the pop-up initializes, we can just run Spark shell and you'll see it come up. And then we'll destroy the cluster. And so that's about it. Feel free to drop any questions you have as I go along with this demo in the YouTube chat. I have it open, so I'll be able to see it, as well as Akwi, who's our co-organizer for this event as well. He'll be monitoring, interacting in the chat as well. And while you're here, don't forget to like and subscribe so you can keep up with all of our videos and upcoming posts as well. So with this, the first thing that we're going to do is we are going to sign into Astra, and we're going to create a token, right? So with this token, we won't need the actual token value. We'll need the client secret and then the client ID. So what we're going to do is just go into our billing settings, and we are going to go into token management. And we are going to just do admin just to make it easy, generate the token. And so what I'm going to do here is I'm just going to copy these into one of my notepads real quick that I have up on a different screen. Obviously, you can download the CSV format of this, but I'm going to just store this token as soon as this is done. So now that this is done, let's take a look at the data that we're going to be querying with our Spark command, right? Our Spark job. So let's go into my dashboard here. So I have this database called Databricks, probably from one of my old talks for Data Engineers Lunch or Cassandra Lunch. But if I go into this Connect or SQL console, I have a couple key spaces, but the main one we're going to be focusing on is the test key space. So if I do select all from test.chipotle stores, and this is some dummy data that you can import using DataStax's Astra data importer, so you can generate data in your database for testing purposes, which is what this data is. And so we have this data here. So we see Chipotle restaurants, state, location, address, latitude, longitude, right? So what we're planning on doing is submitting a Spark jar, which I've already compiled for us, which is going to take the arguments we pass in for the Spark jar and then load those into the jar, run the code, and we should, in the log of the Spark job, get our data frame outputting at least the top 20 rows, right? Because generally it doesn't show more than 20 when you're using the show method. So first things first, what we're going to do here is we are going to create a cluster. In Dataproc, we can select on GCE or GKE. Again, we're going to be focusing on GCE, compute engine. And you can arbitrarily name it whatever you want to do. You can pick your region. Picking your region is important because when you select your jobs, you have to submit your jobs in the same region that your cluster exists. Or if you have multiple clusters, whichever region you want to fire that job on, it has to be in the same region, right? So we're just going to do US East 1. For cluster type, we're going to do standard. And you can configure your cluster as normal, but we're just going to go with the defaults. So as standard, typically what it does is one master node, 2 workers, right? So we're just going to leave that as is. Auto scaling policy, we're going to leave it as is. And here, as mentioned, right, so we have the release versions. So you can change your image type and release versions. Because we're using 2.0, we're going to have Spark 3.13, right? But if we changed it to 1.5 Debian, it would be Spark 2.4, right? But we're just going to leave it as is. And then here is where we can also add additional components. Say we wanted to add Presto to do Presto on Spark. If you're familiar with that, we talked about it a very small amount, but we might come back to that specific concept later in the future. But you can have stuff like Jupyter, Zeppelin notebooks for additional BI, etc. But we're not going to enable anything here. We're just going to leave it as is. And configure nodes, again, this is where you can actually change your machine types and then how many machines you want. But again, we're just going to have one master, 2 workers, and that's it. So coming into customized cluster, here is the important thing, right? So if you have a network, select your network. Again, I'm just using default. I don't have any network tags. I don't have any firewall policies currently. So the next thing we need to do here is go into our cluster properties. So here's where we need to add our conscript provider, right? So I just got to rearrange this real quick. So what we're going to do is here in our prefix, we need to set Dataproc. Then in the key, we need to say Dataproc conscript provider enable. And then we're going to say false, right? And then that's it. That's all we need for setting up the cluster. You can also do additional stuff. You can manage security, but as is default, this will work. So we'll go ahead and hit create. And while this is running, again, as they mentioned, only typically takes around 90 seconds. So this won't take very long. So while that's happening, we'll take a look at my bucket, right? So in this bucket, I already have my Secure Connect bundle, and I already have my jar. Again, this will be available on source control publicly on Monday. But for now, I already have my compiled jar, which does the select all from Astra database .keyspace.table, sorry. And then we also have this variables JSON. Again, you can ignore this. This will come into play when we're doing our DAG, right? So what the main things we'll need are the GS. So if you go to the three dots over here, we'll need this GS util URI. So that's how Spark Dataproc specifically is going to know where our jar location is and where our bundle zip is, right? So if we go back to our clusters, it should be up. So I'm just going to do a quick refresh. Okay, still provisioning. So what I'm going to do for now is I'm just going to copy these down so I can paste them quickly. So that is the jar URI, and then this is the zip URI. And again, this zip Databricks, this points to my specific database. If you don't know how to get this bundle, what you can do is go to your go to your specific database you're trying to access. If you go to the connect section, you can click this connect button, or that would auto direct you here. But essentially, if you go to one of the connect using a driver, you can download your bundle from here. And it's the same bundle no matter which driver, programming language you select. It'll be the same. But let's go back to our clusters. We see our clusters now running, right? So if we actually want to confirm that our property came in properly, if we click on the cluster, we can go to configuration. And then under configuration, we just got to scroll down a bit and we can see this show properties, right? So if we hit show properties and we look for Dataproc, we see our Dataproc and script provider enable false. All right, so now we are ready to submit our job, right? So if we go into our job section, we can hit submit a job, right? So again, you see how this region says US Central 1? If I try to hit cluster, nothing will show up, right? Because we launched our cluster or we only have one cluster running and it's currently in region US East 1, we need to swap our jobs region to match that, right? So if we go to US East 1, now we see our cluster show up, right? Again, you can name your job ID whatever you want. I'm just going to leave it default generated as is. So here, our main class, the one I'm using is Spark Cassandra.poc, and that's what's defined in the Scala code, which the jar is built with. And then our jar file here is where we can pass in our gsutil URI. So if we come back here, we want the jar gsutil, and we paste that in. And that's all it is. That's all we need to do to talk to have our Spark job run our jar from the GCS bucket, right? Archive files, if you have any archive files, you can add them here. And then they have some description for more clarity as well. Arguments. So this is where we need to pass in stuff that we can actually use to talk to Astra, right? So the first thing that we'll need is our bundle path, which again, these map to the actual Spark code, which will be available on Monday. So what we're going to do here is copy the first argument that we need is our zip path, right? So currently it's in the GCS bucket. The next thing that we'll need is our client ID, our token client ID, and then we'll need our token client secret. And then the next three arguments are your database name, your key space name, and then your table name, right? So the first one is going to be Databricks, which is my database name. Next one is test, which is my key space name. And then my table name is called Chipotle Stores. Chipotle Stores, right? So that's about it. Those are the only arguments we're going to pass in. So again, this job, what this jar is doing is just saying, select all, show me the values in the Spark logs, right? And again, the last remaining thing we need to do here is add our properties, which is our Spark jars. So let me copy that in. So we pass in Spark jars packages, and then we pass in the value. Again, because we're using the image version of 2.0.x, we're running Spark 3.13, and because of that, we're using the Spark Cassandra connector 3.1, right? If we're using Spark or the Debian image or Ubuntu image or Rocky Linux image of 1.5, that would be running Spark 2.4, and then that would require us to use the Spark Cassandra connector for that, right? And you can find that matrix on the Spark Cassandra connector GitHub. But yeah, this is all we need to configure our job, right? So if we go ahead and hit submit, we'll see our job clarifications. If you want to confirm your configuration, you can press the configuration here, and you can see what your Spark job, oh, I realized I made a mistake. So let me actually go ahead and go back here to the jobs. I forgot to change the job version, apologies. So I'm gonna hit clone real quick. I imagine that job's gonna fail out, which is not a problem. But what I'm gonna do is job type here. This is what I mentioned before, right? Because Spark, you can run Spark, Spark R, PySpark, Hadoop, etc. So we need to make sure we select our specific job type, which is Spark. All right, and then again, main class jar is going to be Spark Cassandra POC. Our jar file path, let me just copy it back. Jar file path. And then our first argument is going to be our connect bundle, and then we need our client ID from the token. Then we need the client secret. Then we need our database name. Then we need our key space name, and then our table name. All right, and then it still maintains our properties when we cloned it, right? And then if we just scroll back up, make sure we got everything properly. Jar file, arguments. Okay, cool. So let's go ahead and submit this now. And if we actually go back to our jobs, we may or may not see, okay, yeah. So because we have a fail here, right? Because our our job type was Hadoop for the first job we submitted. If we now go back to our second job and we look at our configuration here, okay, job type is now Spark, which is what we want. Our class looks right. Our jar file path looks right. We have our properties. It's picked up our Spark Cassandra connector, and then we have our arguments, right? So our zip URL, client ID, client secret, whatever. Then if you have any labels, etc. And the cool thing is you can actually see the equivalent rest of this, which is pretty interesting. GCP makes it easy for you to be able to do that. But if we look at our job here, we see our data. So we've run a select all from our our DataStax Astra database key space table, right? So with this, we return the top 20 rows, right? Because that's what the show method does. But yeah, that's about it. That's all the configuration you need to do to get Dataproc to talk DataStax Astra. Again, your jar code, it can be different. You can run different workloads. Again, this is mainly just to show you can connect the two. But again, the main things that you need here at the job level is your properties, Spark jar, so the Cassandra connector. And then at the cluster level, you need the show properties. You need the Dataproc conscript provider enables false. All right. So let me open up the floor to any questions. Let me switch back over to here to YouTube. So what does the conscript option actually do? I believe it allows it it has something to do with the preset Spark properties, I believe. Let me just confirm that is true. Let's go to the properties real quick, just to make sure I'm right on that. Conscript. Yeah. So, okay, so that doesn't actually provide much context into what it does. So it looks like it's potentially related to SSL. So I think it's, that's right. That's right. Apologies. When I was first testing this out, I was running into SSL issues when talking to talking to Astra from Dataproc. It would essentially be a handshake error. And we actually worked with DataStax on this. So shout out DataStax. They helped us find that when we set this specific property to false, it helps resolve that SSL handshake issue. That's what it does. Yeah. And feel free to drop more questions in the chat. But for the most part, that wraps up the main part of the demo. But we're going to take a look at now, before we destroy our cluster, is we are going to actually SSH into the node. And I'll show you how to do that, right? Just in the UI itself. Obviously, you can always SSH in the node, but you'll need to manage your SSH keys. But clicking on your cluster and clicking on the individual cluster, if you go into VM instances, and then if you want to go into a worker node or specifically the master, you just need to hover over which one you want to go into. So what I'm going to do here is I'm going to click on SSH here, and then that will bring up a pop-up. I'm not sure if this pop-up is visible, so just give me a second to see what happens with the replay on YouTube. If not, I'll have to reshare my screen real quick. But at the same time, this is just loading. Okay, so it looks like you're able to see the SSH browser. So you see here, we have our user and we have our cluster that we're logged into, right? So if we want to run Spark Shell on here and just want to throw stuff at it, right? We want to test our Scala code or PySpark or whatever you're using. What you can do is just run Spark Shell as is. And you'll see that it actually starts up Spark Shell. So this makes it a really easy way to test Spark code, just test your connections to stuff. If you want to do a Spark submit, you can also do a Spark submit on here, but you can also start your Spark Shell if you want. Similar to this way, but say if we're essentially doing what we did with the job, and we did our Spark Shell, pass in the package, -- Spark Cassandra auth username, Spark Cassandra password, auth password, and then our jar code that way. That's also available. You can also do it this way. But for the most part, this is an easy way to start a Spark Shell on your Dataproc and use it however you want to. But yeah, that will go ahead and wrap up what I have for today. As a preview to next week, we have this POC.py code. So what this POC.py code does is it takes what we did manually when we set up the job or the cluster itself. So when we looked at defining what the machines are like, what properties we want to have for that deployment. If we want to have default networks, we can. But we'll show you how that maps to actual DAG code. So we have a Python dictionary that says, here is our cluster config specifically for GCE. By default, it uses GCE. So if you wanted to use Dataproc on GKE, you would need to use a virtual cluster config, which would require using, for example, your actual cluster, your Kubernetes cluster, and then your node pool. You would need to have your node pool and then your pods, et cetera. But we'll get to that in the future once I have that part of it working. But for the most part, we're able to have a DAG that runs the same exact clustered creation, submits the same exact job with the same exact arguments. But again, we'll be, instead of putting the arguments in manually, we can fill them in using this variables JSON. And then the one difference that we'll have in order to talk to GCP in general is we have this service account, right? And within the service account, we have a key. So one of the things you'll actually need to run the Airflow code is a service account and a service key. And we'll talk about that on Monday, but essentially it's the way that you use or essentially authenticate the GCP connection with the Google provider for Airflow. And within the Google provider, it has all the subsets. So you only need to download the top level Google provider, and then it has all of the GCP, Dataproc, GKE, everything else built into it. So for the Airflow specifically. But if no one else has any more questions, we will go ahead and wrap up for today. Thank you everyone for joining us here at Cassandra Lunch number 115. And with that, we will see everyone on Monday for the extension of this talk, where we'll focus on wrapping everything that we did here with Airflow. And stay tuned for next week. I believe we have an upcoming talk about Yugabyte, and we're going to be talking about building an app with Yugabyte. So if you're not familiar with Yugabyte, you can check it out. And with that, we'll go ahead and wrap up, and we'll see everyone next week. Take care.